Good morning. I'm James Sansini with Netreo, and today we're going to be discussing some of the finer points of managing multi-cloud and serverless environments. During the presentation, if you have any questions, please type them into the questions section of the webinar interface, and we'll be sure to address them as they come up. So first, let's define a few terms so that we're all on the same page. Over time, the cloud itself has evolved, and originally, this was really just hosting hardware and co-location facilities to get closer to the large internet trunks or to eliminate the need to maintain our own complex data center environment. But with the advent of virtual computing, the cloud really started taking off. We no longer had to worry about physical hardware, and we could easily move or replicate resources across the cloud. Large cloud providers like AWS or Google Cloud Platform provided an easy and scalable way to move our workloads into the cloud and often were very cost effective. More recently, organizations have begun using microservices architectures like containers to make this even faster and more agile. So the DevOps approach usually leverages this to get faster deployments to production and even better scalability. Container hosting also allows us to get even more abstraction from the physical infrastructure so we can ignore provisioning requirements, and it makes dynamic scaling faster. Serverless computing is really just the next evolution of this process. So sometimes referred to as function as a service or FaaS, this approach means we now only pay for the actual CPU cycles our code uses and makes automatic scaling effortless. However, it does carry with it some additional visibility challenges, and today we're going to talk about addressing those. Together, container and serverless architectures are sometimes referred to as dynamic cloud architectures to differentiate them from the older static cloud models where we have predefined provision systems floating around and we're paying for them even if they're idle. So where are we at with adoption? Today, the majority of organizations are already at least partially in the cloud, and a slim majority of them are using a hybrid cloud approach, where some of their resources are hosted on premise, and some of them, usually the customer-facing parts, are hosted in the cloud. So this allows for a high level of adaptability and is really well suited to moving existing workloads into the cloud, so you can understand why it's so popular. Of those, 81% are using multiple cloud providers, which helps avoid vendor lock-in and can provide additional redundancy or meet different needs for different groups within the organization. But this approach can add complexity, and interoperability and portability between providers can become an issue. So some of the latest surveys indicate that as much as 90% of the cloud workloads in use today are static cloud architectures, which means we're just now at the dawn of the dynamic cloud. Dynamic cloud adoption is expected to increase by over 350% in this year alone, and the dynamic cloud industry is expected to grow to over $7.7 billion by 2021, representing one of the fastest growth rates in technology today. Of those organizations who are already using dynamic cloud architectures in production, the adoption rate of container-based versus serverless is almost even. So container orchestration allows a lot of the same benefits as serverless architectures, but with more control over the environment. However, that approach comes with an increase in administrative overhead, complexity, and slightly more difficult scaling implementations. So ultimately, the advantage of a fully serverless architecture may drive that to become the future of the dynamic cloud. So let's look closely at what the differences between those are. So containers offer considerably reduced administration compared to full virtual systems, while still allowing for a consistent development environment and allowing you to have full control over that. This can be really important for some legacy applications, and it may be a transitional step away from static cloud workloads. But if you have to refactor the applications anyway, then moving directly to serverless might be a better plan. Containers also allow you to easily scale applications and distribute them across multiple cloud providers or data centers, but there may be some development required to fully automate and tune that process. Serverless, on the other hand, reduces the admin and dependence on the infrastructure and hardware even further, creating a pure code type of environment. It pulls the hardware and scaling factors entirely in the hands of the fast provider, which makes that choice extremely critical. It also completely eliminates the requirement to manage an environment at all, which can improve security in a lot of cases, and it allows for completely seamless and automated scaling of the applications. However, it does come at the cost of reduced control over the environment, and that can potentially have an impact. For example, if an update to the programming language or libraries is going to change the way a particular function works, I might have to scramble to refactor my code to do the update if the old version isn't an option for my provider. So we've seen this happen with things like new versions of PHP coming out, or new versions of SQL where the code just doesn't work exactly the same way, and we've got to do that refactoring. We may just have to do that on the fly if suddenly the provider decides that they've set a deadline for the upgrade and we don't have the control to run the old version. Now, whether you're using the dynamic cloud and are kind of really on the cutting edge, or whether you're still on a static cloud approach and using multiple cloud vendors, like most organizations are today, the management and visibility challenges of these environments have a lot in common. For example, many tools are slow to adapt to the rapid changes in deployments, and that can lead to blind spots. So you may find yourself missing issues if you're not watching things based on a services first approach. The visibility often can suffer as well when it's difficult or labor intensive to manage. In an environment where resources are added and removed on demand, you really can't use a manual process to monitor those systems. It has to be fully dynamic. And the more tools you're dealing with, the more likely they are to contradict each other. To say nothing of the increased admin and training burdens and the communications issues between teams that this can cause. Some cloud providers try to lock you into using only their tools, and while they may have a great tool, it probably doesn't monitor all of your other cloud or on-premises resources, and now you've got multiple tools to administer and many different places you have to look during a crisis. Lastly, without hard data to keep tabs on exactly what's running and how it's being deployed, it's really easy to let the cloud resources run amok, and that can add a lot of unnecessary costs. Some of the most common approaches to visibility today weren't really designed for these kind of complex multi-platform environments, and it can leave you stuck in firefighting mode. So a lot of the organizations we speak to are still using reactive alarming, and that means they're not finding problems before they start impacting users. The lack of automation is also a really big factor because the admin and training burden of running multiple monitoring platforms means they're wasting a lot of time and are probably never keeping up with the speed of deployment. Most platforms also suffer from slow or cumbersome reporting and little ability to customize or automated or really complex options for customizing reports that can be difficult to manage and difficult to keep up with over time. And that can really lead to a lack of hard data that you can use to make planning decisions or to efficiently plan how you need your automatic scaling to work or to evaluate how well it worked after a sudden flash load. So to get all of this under control, we should always start with the process. By adapting our action plan so that the platform hosted applications are included in how we're thinking about the monitoring and alerting process. One good example of this is if we're moving our email to Office 365, which is a really common one, our escalation times and response times and notification times should all be synchronized to work with the SLA that we've got. We should also make sure that we have a clearly defined process for how to deal with mail issues, such as technical resources in the NOC who are trained in the use of the Office 365 admin console and have the right phone number and contract numbers for vendor escalation in the event of a problem. You should also try to make sure that you're building your own telemetry into your applications. So not all container platforms or fast providers are going to have complete metrics available, and none of them are going to be able to see into your application internals. For example, we can easily add an API to our application that would check the status of the business logic or provide a useful metric like the number of logged in users or the number of successful and failed transactions in the last few minutes. And if we do that, it makes the long-term metrics and reporting a lot easier. So if we're actually going to be refactoring the code to take advantage of something like serverless architecture or container-based architecture, it's important to kind of include some telemetry in that design process because it's often difficult to retrofit later, but it's really not that hard to include if we're doing it from the beginning. We also want to integrate all of the data across the enterprise. So it's really a key factor in making this a successful deployment. And this has always been the goal of OmniCenter since the very beginning. So we want to watch out for things like cloud platforms that don't provide good APIs or that force you to use their dedicated monitoring. Because again, having to look in multiple places to get a complete picture of what's going on is going to cripple problem resolution times, and it's really going to make correlation and root cause analysis very difficult. But by integrating application level and system level metrics into a single user interface and have consolidated reporting for all of that, we can really enable the system to detect correlations for us. And we can allow the operators to better find the cause of problems without having to go on a scavenger hunt through multiple systems to figure out what happened when. Managing multi-cloud applications doesn't really need to be the hard part. So what we really need is a single centralized point of management across all the environments, no matter where the applications are running. And because the public and private cloud infrastructures are operating independently, it's critical that we use a technology that provides portability of data and applications between clouds and that can detect and provision newly deployed resources quickly and completely. So the higher up the stack we can test, the better. When we're talking about very abstracted services like containers or serverless applications, testing at the application level is the best way to make sure everything is working properly, and that should be integrated into the single pane of glass that's monitoring the rest of the environment as well. And while it's critical to share the data between the teams, it's equally important not to let individual teams perform their own monitoring exclusively. We should absolutely make sure that the team has a view of what the command center is seeing, but it is not okay to let them perform the monitoring instead of doing it centrally. And all of the departments and teams really need to share a single view of reality in order to make sure that we've got fast incident recovery and good communications between the teams. Teams that perform their own monitoring with no oversight tend to hide their dirty laundry, and they also tend to apply temporary fixes so they can get out of the spotlight faster. As a result, you'll end up with more outages, longer outage times, and a higher percentage of recurring outages. And because there's no oversight, senior management is often unaware of the number or scope of the outages, and that means they can't direct resources to the right places. Has anyone ever heard someone say, well, we didn't budget to upgrade that system this year because we didn't know it was having problems? It's a very common sort of issue you have when you've got all those different teams doing their own silo monitoring and not really reporting up, or there's no central oversight. So by keeping the marketplace open and using different providers, we can take advantage of the myriad options that are available to lower costs and increase performance, especially if we're building a multi-platform application that utilizes best of breed from multiple providers. So multi-cloud computing is getting more and more popular because it offers its companies flexibility, scalability, and agility, but we need to be really careful of vendor lock-in. One of the most common complaints today about serverless architectures is that all the top cloud vendors are developing serverless specifically with an eye towards achieving vendor lock-in. They're deliberately designing the systems not to interoperate. So we need to be really careful of how we leverage those platforms in such a way that we give ourselves the mobility that we need, or that we're pressuring our providers to make that interoperability happen as much as possible. Putting multiple clouds together requires automation tools and management capabilities. So we need a system that's efficient, reliable, and cost effective over the long haul. When we're managing applications that are this complex and abstracted, we need to have a way to profile and identify what's going on. So the idea here is to detect unusual behavior instead of just alerting when a failure occurs. So almost any monitoring system is going to allow you to create static thresholds of monitors that will alert when there's a failure. But once that happens, we need to scramble to restore service, and that means impacted users and making rush changes that can introduce new problems of their own. So getting to see in advance when something is acting unusual instead of relying on that fix on fail message is a great way to start to get ahead of the firefighting curve. So for example, if I get an alert saying that the Java-based client tracking system is suddenly using 50% more memory than is normal for this time of day on this day of the week, it gives me a way to investigate what's going on and fix it before the application actually falls over and we have a bunch of calls into the help desk. So once we have that baseline created, we can start looking at long-term trends and use automated reporting to make sure that we don't miss anything. For example, I can get an email every morning showing me which systems had too many login failures, or when an application used a lot more compute resources than is normal for that day of the week. The reason most companies don't get to this point is that trying to create and tune a performance baseline even for a single system can be really time consuming and difficult, to say nothing of doing it for hundreds or thousands of different systems or applications or network devices and trying to keep up with it as new applications are deployed, business processes change, new systems are deployed, or I've got dynamic performance on demand going on in my serverless or my container environment. It can be really hard to keep up with. So even a large company that has a dedicated staff to do this is going to have trouble unless they have some way of automating it. So our approach to that problem is anomaly detection. And the technology that we use to make this process automatic is this anomaly detection technology. So the idea is that we're constantly logging performance telemetry on all of the different monitored devices and applications, including metrics like the number of log messages received, CPU and memory usage of each process running on a system, all the different types of metrics that we can watch about a system are always constantly being logged and monitored. And we can use this to automatically generate a baseline behavior model using the historical data that we retain. And for most statistics, that's 100 days, and automatically adapt the baseline as the environment changes and evolves. So we can then compare what's going on right now at this moment with what is normal for this time of day, day of week, or even hour by hour. We can also set the sensitivity of the detection to high, medium, or low, depending on the tolerance as an environment to what the usual range of that statistic is, so we can fine tune this process. And then that information is used to detect when something unusual is happening. So we can flag that as an anomaly that can generate alerts or reports. So this allows us to find unexpected impacts a lot of the time. For example, One customer of ours discovered an issue because at 10 a.m. on a Wednesday, the database server is normally running at 50 to 60%, but suddenly it was running at 15%. And it turned out that a minor bug fix that got pushed to production had put the wrong API key in and had broken a form deep within the application where the front end team didn't notice it. So customers weren't able to complete the orders properly, and that was reflected in the database load. And a change like that, a sudden drop in CPU usage, is the kind of unusual behavior that would never trigger a static threshold, but in this case revealed a problem long before they noticed the drop in orders and the lost customers that might have resulted from that. You can also track things like log messages for a specific problem, like looking at the volume of transaction failure messages might be very informative. If suddenly it jumps from 3 per hour to 100 per hour, it might indicate something's going on with the application, and I've got a starting place to go look at to see what's causing that problem. One of the fastest ways to get out of firefighting mode is to make sure that we're not spending all of our time um, putting out fires at the expense of dealing with the real business requirements and moving the organization forward. So the most effective way to do that is reduce the amount of alerts we're sending out of the system. So our recommendation has always been reserve alerts only for things that are truly immediately actionable. Metrics that are just good to know should be eliminated from real-time alerts completely and mercilessly. Because if you're not going to react to the alert, don't send it. Instead, use reports. So if we're not going to immediately intervene for a high CPU on a server, maybe we're better off getting a daily or weekly report so we can keep an eye on it without waking somebody up in the middle of the night to fix it. And our tool makes this really easy to automate and schedule these reports even without training, so you can make sure that you don't miss the ongoing trends that indicate things like the need for environment tuning. Another great way to get control of alerting is to integrate automation. So automation comes in a few different flavors, and the first place to look at is automating the response to alerts, so we can eliminate the need to send notifications at all in many cases. So you can do things like link CLI commands like SSH or PowerShell or API webhooks, so that you can have the monitoring system do things like restart ports or retest applications or even dump real-time diagnostics in response to an issue. This can make it really easy to hunt down things that are only happening intermittently. If we can dump a process list every time we have a problem on the system, we can catch very short-lived transient problems without having to wait for them to recur over and over again so that we can reproduce them. Now, some folks are uncomfortable with automatically executing commands. So we give you the ability to control those commands manually through operator intervention if you prefer that approach. So if you want to add a click to restart server function into the web interface of the monitoring system and limit that access to just administrators, there's a really easy way to do that. One of our customers even set the system up so that after hours, it restarts the server automatically and notifies the NOC. But since the NOC isn't staffed full time, they're trying to get that response before a human has to actually intervene. But during business hours, they're just sending the alert to the NOC, so the NOC can make the decision as to whether or not they need to restart the system. However, keep in mind if you're doing this kind of automation, maintenance windows are absolutely critical. Otherwise, a scheduled software upgrade is not going to go like we expected because the monitoring system is going to start doing things in the background. So nothing really is more frustrating than shutting down the application for a minute so that I can do a software upgrade and everything's planned and nicely going, and suddenly the server reboots on me because the monitoring system did it and I didn't tell it not to. So we provide a really easy web interface to create maintenance windows, or you can even link directly into your change control process via API if you like. Another best practice recommendation we often give customers is to use distribution lists and not individual emails for things like email alerts and automated reports. And there's a few good reasons to do this, but one of the key ones is to better keep in sync with personnel changes. So there have been more than a few incidents where a problem was detected by the monitoring system, but the alert went out to an abandoned or an invalid mailbox, and this caused a significant delay in detecting and acting on the problem. It also allows you to create an easy historical archive of things like automated reports so we can share them in a central location. So if we need to go back to the weekly performance reports from 2 years ago, last September, they're easy to find and locate, even if the detailed data has been rolled up by now. By making monitoring data visible to everyone in the value stream, everyone can share a common view of reality, which aids in communications and demonstrates transparency, which enhances trust. So a key element to making this successful is to make it easy and quick to access the information, so teams don't feel like they need to have their own monitoring, which can create a lot of alert noise and redundant effort, as well as creating admin support and maintenance spend issues. So if the audience is non-technical, and in every company, there's always some non-technical people that we have to keep in the loop, don't hesitate to simplify or abstract the data into easier to understand formats. We do this with our business workflows functionality, which allows you to roll an entire application and all of its component parts into a single percentage score. And sharing the data can take a number of different forms depending on what works for your environment. So APIs, share pages, intranet pages, unauthenticated pages, and information radiators are some great examples of how to use that. So an information radiator is just a system designed to display status information in a public area. For example, a monitor on the wall of a hallway that everybody walks through. So the team can display metrics using custom dashboards or business workflows functionality in order to share useful data with the team. Certainly things like current incidents, but also operational metrics like response time, transaction velocity, system or application status. It also allows us to actively demonstrate our core values. So things like, the team has nothing to hide from visitors, customers, stakeholders, but also the team has nothing to hide from itself, that they're acknowledging and confronting their problems. This is part of that transparency enhancing trust approach. Now, as I mentioned, a key factor in making information radiators work is to make them easy to understand. So our business workflows functionality is designed to allow you to group arbitrary systems together so that you can see all the different parts that are required to make an application work. So databases, storage, load balancers, clusters, group those into a single easy to understand percentage metric that can be monitored and trended over time to detect anomalies or to manage service level agreements. You can also control how each different item is weighted, so only the key metrics or services on each system get counted. So the numbers reflect the reality of how the applications are doing, and systems can be part of multiple groups. So I can have one group for storage that the SAN team focuses on, but the storage arrays are also part of the different applications that depend on them. So the app teams can see when a problem might be coming from storage, which cuts down on resolution time. You can also then combine multiple groups into aggregate groups. So for the CIO's dashboard, she can have a single metric for each line of business or area of responsibility that just says network, security, remote offices, and know immediately if everything's good or if something's being worked on. And we can monitor this using auto configuration rules to populate all of these items automatically and maintain that configuration going forward. So we're not adding administrative burden trying to keep this up to date. Now, monitoring from where the users are accessing the application is key, and we integrate a network of what we call remote reflector systems. These allow us to monitor public-facing sites from all around the world, even if your monitoring system is on premise. Now, we provide a network of these that we manage so that you can use for public-facing applications, or you can deploy your own if you've got private cloud monitoring. You can also implement OmniCenter fully in the cloud, so you can get access from anywhere or deploy remote collectors, what we call service engines, in as many different clouds as we like, while keeping our monitoring system on premise. And this allows us to get deep visibility into the application performance and test for multiple locations simultaneously. So I can determine immediately if my applications only have a problem when they're being accessed from my European locations, or if I'm having a problem with East Coast versus West Coast due to BGP routing problems at my provider. I can see those issues and isolate and identify them, so I know exactly who's being affected and what is being affected by them. Now, long term, public clouds can be very cost effective, but the price can jump quickly with heavy usage. So if we're using a dynamic cloud that continues to scale as needed, our usage costs can go up very quickly. On the flip side, setting up a private cloud is not an insignificant endeavor either, and 19% of new serverless implementations are still being done in on-premise clouds. So we need a good source of strategic decision support, and comprehensive reporting integrated with the monitoring system is the easiest way to get it. OmniCenter can not only monitor in-house, public, cloud, containers, and serverless applications and resources all in a single integrated dashboard, but it's also specifically designed for long-term data retention, automated baselining, and automated reporting, so you always have the data that you need to make the right decisions quickly. Now I'd like to take just a moment to address any questions that you've got. So I'm going to go through the questions interface here. We're also going to launch a poll now. So if you'd like us to follow up with you and discuss your specific environment or answer your questions in private, you can use that format to let us know, and we'll follow up and contact you. So the first question is, how is OmniCenter priced, and is there a charge for the different kinds of application monitors? So Our pricing model is based on strictly a number of devices and application tests. It's designed to be as simple as possible. There's really kind of two sorts of device licenses. One is a full device license where we do comprehensive monitoring, and the second one is a light device license where we're only monitoring for ping. So if I have systems that I know I need to monitor up-down status on, but I don't have access to get the full stats on, or I don't have the ability to get in-depth API metrics from the system, I can at least monitor up-down status that way and do it with a less expensive licensing format. The next question is, how far does OmniCenter scale? So in a virtual environment or a cloud-hosted environment, it really just depends on the resources allocated to the system. But we've got customers who've had cloud systems scaling up to 10,000 or so devices within a single cloud instance. And of course, you can cluster multiple systems together using what we call our overview technology to allow you to scale this almost in an unlimited fashion. With the hardware platforms, they come in different sizes, and you can deploy a hardware platform anywhere up to 25,000 devices under management in a single platform. But those are becoming less and less popular as more companies implement more cloud-based systems and more container-based systems and more virtual systems. Okay, well, thanks for joining us today. I hope you picked up some useful tips to improve and simplify your multi-cloud and serverless management approach. And as always, if you have any additional questions, please feel free to send them to us at info@netreo.com, and we'll be sure to get back to you right away. Have a great rest of your day, everyone.